Your muscle fibers have a built-in ceiling. As they grow from, for example, doing resistance training, the inside gets harder to reach. Oxygen struggles to get in and waste products struggle to get out. So your endurance naturally plateaus. But with the right training, you can push right up to that ceiling without sacrificing strength. And in this video, I will break down the latest science on how to build strength and endurance at the same time, simultaneously. And I will get into what the latest science says about beating that biological ceiling so you can apply that to your own training and tap into your full potential. All right, super excited for this one. Let's go straight into it. Hi everyone, welcome back to another wod-science video. My name is Gomar, I'm a senior scientist at ETH Zurich based in Switzerland. And for the last decade or so I studied and taught different aspects of exercise physiology, and my goal now is to bring some of that science that I learned back to you guys. So if you have been watching my previous video, I've been talking a lot and in great detail about the constraint hypothesis. And basically what that means is that muscle fibers can only get so big before oxygen delivery or oxygen diffusion becomes a problem. And it's not only about oxygen diffusion, it's also about getting rid of the waste products that are accumulated inside the muscle cell. It makes sense. The bigger the muscle fiber, the bigger the distance between the capillaries or the surrounding of the muscle fiber and the inside of that muscle fiber. So that is basic physics. I think it makes a lot of sense. That's also why you see endurance athletes having more thinner fibers, because it's easier to deliver all the nutrients, all the oxygen inside the middle of the muscle fiber. But then interestingly, there also seems to be some kind of biological ceiling to how many capillaries that can be added towards the perimeter or the surrounding of a muscle fiber, because the more the muscle grows in size, meaning the cross-sectional area grows. For example, when you're doing resistance training, the cross-sectional area grows faster than the perimeter. So this means that there is a biological ceiling to how many capillaries or oxygen delivery capacity that can be added towards a growing muscle fiber. Obviously, this is kind of theoretically. Where is that biological ceiling? Is this different for everyone? But most importantly, and that would be the focus of this video, how can you get as close as possible to this biological ceiling without losing strength? Because yeah, you can just lose strength and therefore this capillary to fiber ratio will improve. But the goal of most of the hybrid athletes or people who are watching this video is that you don't want to get lean or too lean. You want to remain bulky and still gain endurance, gain cardiovascular capacity. So I will dig into a plethora of papers that look into how to beat that biological ceiling, how to train concurrently, train both strength and endurance, and how you can implement that into your training. So bear with me, I think this will be a masterclass on concurrent training, hybrid training. Good, so when we talk about building strength and endurance at the same time or simultaneously, we have to talk about the interference effect. An interference effect basically means that there is an interference between your pure endurance type training, for example, cycling or HIIT training or medium intensity long rides or long runs, and your pure strength training, leg press, back squats, deadlifts, and so on. That those signals interfere, right? That's the major point that you have to take into account. And there has been a lot of research on this, mostly in traditional sports. As I said, mostly cycling, running, and then combining that with typical globo gym stuff where you do leg presses or calf raises or bench press and so on. And there's a major study that looked at the overall, or that reviewed all those studies. And this is what we call a systematic review. So it takes into account, in this case, 59 studies and 1,346 participants. So it pooled all the studies and then looked, okay, is there actually an interference effect between if you do only strength training compared to you do strength training and then right after, so concurrently, you do your endurance training or vice versa. And in males, right, lower body strength, I'm talking mostly about strength today, so not really hypertrophy, that would be for another video. I'm mostly talking about strength. There seems to be a minor or at least some interference effect. Here you see a force plot of different studies, and when the study is left of this middle line, this means that there is a favor of doing only resistance training when you are looking to gain strength. So I think, 8 studies show indeed there is an interference effect. 5 studies show there's not really an effect, but if you add them all up, there is a minor effect. So this is a statistical representation where you look at the standardized mean difference. This is not the exact, let's say, you have 30% less strength when you train concurrently. No, this simply means that there is a trend towards a certain direction. And in this case, the SMD for the males was 0.4 or 0.42. This is a minor to moderate effect. So there is an effect, but it's not massive. We're talking about a couple percentages less gains. Interestingly, the women, although there were less studies, did not show this kind of trend. So there was not really an interference effect for the women when you do strength and endurance combined. And when you look at, so this is strength, but when you look at endurance capacity, we'll talk about endurance capacity a lot today. For example, increases in VO2 max. Also there, in males and females, according to this big overview study, there is not really an interference effect. So you gain as much VO2 max by doing just concurrent training or only endurance training. That's quite interesting. But obviously, this is all studies added together. It doesn't really take into account the training volume. You know, if you have been watching some of my previous videos, I always talk about training volume, training load, training intensity. If you look at concurrent training, you always have to take into account the total training volume, or even better, the training load. I will get to that. Meaning that if the concurrent training group has more overall volume, obviously there will be a better effect, or vice versa, when the strength training has more reps compared to the concurrent group, for example. So this study, published I think in 2023, very interesting study, although it has a low amount of participants, looked specifically at that. They tried to equate the training volume of the different groups. I will get into this. I will try to explain this pretty well because we're gonna refer to this study also in the remainder of the video. So they had 4 different groups of male participants. That one group that did only resistance type training, so global gym work, where they trained 3 times per week, just full body split strength training, right? Then they had concurrent training, 2 concurrent training groups. One did high intensity, so they did a strength training protocol, and then right after they did some sprint intervals or some high intensity intervals on the bike, right? Importantly. Then the other group, they did the same, but instead of sprint interval or HIIT training, they did medium intensity, like longer duration, medium intensity bike work, all right? So lower intensity. And then that's interesting here in green, the resistance plus barbell circuit group, this kind of the CrossFit group, they did first a resistance training like modality, and then they did the same exercises, but using lower percentages of their 1RM and doing more repetitions, typical CrossFit style AMRAPs, using power cleans, front squats, and so on. So that's quite interesting. That's also why I added this study, because it is some kind of a CrossFit type group. And then they want to know, okay, is there an interference effect? Do the different groups gain strength to a different extent? Importantly, they try to equate the volume, so the duration of training, to the same extent that all the groups have the same duration of training, meaning that the concurrent group, they trimmed a little bit of time of their pure resistance type work, and which they then could add towards their cycling or their barbell circuit. So the volume of all the groups was equated. I think it's a very important and key factor. So let's look at strength. Here we look at back squat 1RM. So a typical nice, well transferable skill towards, for example, hybrid sports like CrossFit, hyrox, and so on. And here we see that the RT, I will just explain quickly the different groups. RT is a resistance training only. RTC is the resistance training plus the barbell circuit, right? The CTM is a resistance training plus the medium intensity bikers. And then you have the CTH, it's going to be the high intensity groups, the concurrent training, where they do resistance training plus high intensity work. And you see the gains in barbell 1RM is around 15 to 20 kilos, right? Look at the x-axis, and they're all the same, right? There's no significant differences. It seems, if anything, that the CTM, so the medium intensity group, actually gained the most, but this was not significant. So all groups gained the same amount of strength compared to resistance training only. That's very important. These were largely relatively untrained people. That's also something to take into account. So that's quite interesting, right? Like there's not really a big difference here when the volume of training is equated, kind of what I just explained previously. Let's look at something else, like not pure strength, but also endurance, right? Let's look at the peak or the increase in peak VO2 max. I also did a ramp test to exhaustion with a mask before and after the training. And yes, indeed, there seems to be some kind of differences. Here, it's quite interesting. So the CTH and the CTM, so the resistance training plus pure biking, right, seem to gain the most endurance, most VO2 max compared to only resistance training. I mean, that makes sense, right? If you do only strength training and you get bulky, you won't gain any VO2 max. But interestingly, the RTC group, the barbell group, didn't gain any VO2 max here. So it seems to be a good idea if you want to gain like a hybrid style training, you want to gain pure VO2 max, so pure endurance capacity and pure strength. It's maybe better to not do too many barbell circuits like AMRAPs, but rather do monostructural biking work, at least according to this study. And this was indeed significant compared to the RT group. So important consideration here. Still, pure training volume, in my opinion, doesn't mean that much. It could be that for example, for me, if you do a barbell circuit, right, it's actually quite high intensity. Even though the volume might be the same, it is always going to have a higher toll on your body than when you do the same time, for example, 30 minutes or 25 minutes of easy biking, all right? So that is something that you have to take into account, that it's not only the volume, but also the training load. And the training load or the strain on the body is always a ratio of the volume, the duration of training times the intensity. And that's what we did with our hybrid study. So I have already made a video about our hybrid studies, but it's, I think, quite interesting to touch upon the results of these studies because I think it makes a lot of sense in the scope of this video. So what we did 1.5 years ago and now almost a year ago, we set up a hybrid study. So what did we do? We did basically the same as we just explained. You had one group that did strength training and then a barbell circuit or some kind of a CrossFit style workout, right? Like after each other, back to back, so in one session. That was done over several weeks. And then another group separated those sessions. They did the same session, so it was the same training load because it was the same sessions, but they just separated those over. One day was more strength, and the other day was or only skill and more endurance type, like Metcon style workouts, right? So strength and then more Metcon style. And this is also the setup of our hybrid programming that we still have running now, our most popular program, because we see that this actually is a very efficient way of training. But let's get into the data, because I think it relates well to also the study that I just explained of the barbell circuit. And what did we see? That we actually did see a larger increase in some CrossFit specific tests, right? So you see here the commercial, which are the guys who are training concurrently, right? You can also make this concurrent training. And the hybrid 2.0 would be the guys and also the girls who trained rather separately. And you see here, for example, the burpees. They did a burpee test, 7-minute all-out burpees. They improved more in the hybrid style of training compared to only doing the concurrent style of training. So there seemed to be some kind of interference when you look at very specific tests to the sport. The same happened for other tests, such as a functional ramp test to exhaustion, which is kind of a ramp test using thrusters and burpees, where there was a larger overall increase in the people who trained separately. Interestingly, if you look at pure strength, right, so not endurance or CrossFit style Metcon training, there was no difference. There was no interference effect, kind of what we just saw on pure strength events. For example, the CrossFit Total, which is deadlifts, back squats, and presses, there was a similar increase of 5 to 6%, or 3 to 5%, I'm sorry. And then also the clean and jerk, which is obviously typical weightlifting, more neuromuscular. There's also a lot of technique there. There was a similar increase. So in some aspects, there seems to be a minor improvement by doing a separate style of training. And in some aspects, it doesn't really matter if you take all the data together. So this brings me to, let's say, an intermediate conclusion, because this video will be a little bit longer and I try to really dig into all the research that we did, but also that has been done on the subject before, is that bigger muscles obviously make you stronger, but it will be harder to deliver oxygen and also get rid of some of the waste products during more endurance type exercise. So there must be some kind of biological ceiling. How to train that biological ceiling, how to reach that biological ceiling of both strength and endurance is going to be some kind of a concurrent form of training where you both train strength and endurance. Best is to do this likely on separate days. We'll get into that, how to program, but likely there's a minor interference effect where strength is interfering with endurance and vice versa. So the question is, how does this actually work? And now we have to get into a little bit of molecular biology. I did my PhD some time ago, and I focused mostly on one specific protein or protein complex called mTOR, or mammalian target of rapamycin. And we call this the master regulator of muscle growth or of growth of a cell, right? Because it regulates the new synthesis of proteins, also structural proteins. And master regulator, why do I say that? Because it knows, or it can sense, when the muscle is doing heavy contractions, when there is sufficient nutrients, for example, amino acids, mostly leucine, so mostly amino acids. That's why you have to drink or eat your whey protein shake after strength training. And it combines all those signals towards, okay, now the muscle has been stimulated by doing strength training, and also it has sufficient amount of energy, amino acids, so now it can grow. That's kind of the master regulator, right? And then you also have another molecule called AMPK, AMP kinase. And that's kind of the opposite, meaning that it is the fuel gauge of the cell, meaning that when there's low glycogen, when there's low amount of energy, that protein will be activated, and it will mostly relate to or signal towards making more mitochondria, more capacity to build ATP, but also it will break down proteins that are inside the muscle. And what we know from mouse studies, specifically mouse studies, is that when you supraphysiologically like really push AMPK to maximize his activation, there will be a blocking, like a biological blocking of mTOR. So we thought, okay, if you do endurance training, right? AMPK is going to be activated because you use your glycogen, you use all the energy in your muscle cells, in your body, and it will stop muscle protein synthesis because that's a very energy intensive mechanism. Makes complete sense if you think about it. But the interesting part is that more applied studies, and also with muscle biopsies, actually have never shown this in humans. Right? So this interference between AMPK and mTOR is kind of a myth because it has never been shown in real-time or realistic conditions in humans. Important to understand. So yes, there might be something there. Maybe we can not pick up those minute effects. Maybe our technical analysis in the lab are not significant or sensitive enough, but it's likely not a big effect because now 3 independent studies that I have read have not really found this interference between AMPK and mTOR and vice versa. So what I think that is mostly happening here in this interference thing is simply applied. Meaning that if you are a hybrid athlete, someone who doesn't specialize in one specific area of fitness, right? You're gonna have to divide your training load, your total training volume for or related towards the different modalities: strength, pure strength, endurance, and mixed modalities in the case of a hyrox athlete or a crossfit athlete. Compared to when you are an endurance athlete, you're going to do 95% of your total training volume is going to be in the endurance like regimen, and then a power lifter can do whatever 85% of pure strength work, right? So yes, there might be some kind of interference, but purely because you only have whatever 25 hours of total training time that you can handle as a human, you're gonna have to choose. So that's why there is always going to be some kind of interference between your pure strength and endurance, because there's no possible way to combine them all or to specialize in all, because you have to choose simply. And this reminds me on Matt Fraser, right? Matt Fraser, back in the day, I think he became second in some of the early CrossFit games. And he said that one of his major struggles was his pure cardiovascular capacity, because he came from a weightlifting background. So what did they do? He kind of specialized for a certain set of time in pure endurance work. I think he went every day on the rower and did rowing intervals and longer sets of rowing. Same with Claire Toomey, right? In the beginning of this year, 2025, she said, oh, I'm going to focus on hyrox. So she started running. She did predominantly most of her training in running. And then after the Chicago Hyrox World Championships, she said, okay, now I want to win the games or the CrossFit Games. So she did way more strength and mixed modalities. You always have to kind of choose, even when you are an elite athlete. So that is also how we build our programming. When we build, for example, a year programming for CrossFit or also for hyrox, we think in blocks. We do block periodization, meaning that you do 10, 12 weeks of a certain aspect of fitness. For example, for hyrox, it would be predominantly running now. We try to improve your running. We also do the other mixed modalities, functional movements, and also some strength. But our overall goal, because we know that the people only have whatever 10 hours to train per week, has to be running. And then we shift towards another part, which would be more specific towards a certain competition. So if you're interested in training in a more structured way, where we really dial in your training load to be able to progressively overload through time without over fatiguing you, that's super important, in more CrossFit as well as hyrox style training plans, please scan the QR code that is popping up right now. We have a 7-day free trial, so you can just try it out, and you definitely support the channel. I put a lot of effort and time to try to explain and also read all those papers to you. So if you want to get fit and help us out, please have a look at our different training plans. I think you won't regret it. Cool, back to the interference effect. The question now is, okay, so how can I optimally program to be able to mitigate or minimize this interference effect as much as possible? Yes, I have my overall training volume, and yes, I know there's going to be some interference, but I still want to make sure that I don't overlap too much, right? And then there's 3 rules that I always go with. I will explain them now. The first rule is very simple, is try to separate. I already alluded to that in the initial part of the video. Try to separate as much as possible your completely opposing sessions. For example, cycling or running, and then the mixed modalities or strength work. Why do I say that? Because there's actually some good evidence for that. Let me guide you through a paper from the 90s, like 1990. I was 3 years old then when they already were talking about this stuff or even investigating this stuff. And what did they do, or what the title says of this paper? Comparison of 2 regimens of concurrent strength and endurance training. Very straight to the point, very good title. And what did they do? Very simple. They did strength plus endurance training at the same time, at the same day, kind of like our hybrid study. And they did that 2 times per week. So they trained concurrently 2 times per week. And then another group did the same training. So the same training load, that's important to understand. And that's also why I picked the study. But they separated that, or they spread that out over 4 days. So one morning strength, the next morning endurance, strength, endurance for 4 days. Total load was the same. And what did they find? Again, minor differences, but there were some differences. For example, here, 1RM back squat, they found, when you see here the white bars that are the pre-values and the dashed bars or whatever, the gray bars are the post. So they all both improved their 1RM strength, both groups. The left 2 bars are the A group, are the ones that trained concurrently, and the right bars are the ones that trained separately. But quite clearly, I would say, the B group improved more. Again, they did the same training, pretty cool. If you look at endurance, like more VO2 max, there's no effect. Again, we have seen this quite a lot also in other papers and in the meta-analysis, that your endurance capacity is not really affected. So that's quite interesting for pure hybrid athletes, maybe not hyrox, but people who want to improve their marathon time and also strength. You have a lot of people probably also watching this video that are interested in that. It doesn't really matter. So it doesn't really affect this separated training or typical strength training. And then you also have a training, I talked about this, or a study, I talked about this in my previous videos, in rugby players. And rugby players are more functional athletes. They did the same. They separated their training sessions of the endurance and the strength training with 0 hours, so at the same time, 6 hours and 24 hours. And also here they saw that the 6 and the 24-hour groups, where they separated both strength and endurance, saw better improvement also here in VO2 max, interestingly, but also in bench press and half back squat performance. So again, same training style or same training load, but it seemed to be better overall if you look at some of the studies in this area to separate them. So that's rule number 1. If you can, I will get to some nuances later, try to separate. Second is the most important thing about any training program, whether it is hybrid, whether it is pure endurance or pure strength, is that you have to try to maximize the training volume / load according to your schedule. Because It's actually a simple rule, or a stupid rule even, I would say, but there's some very good research showing that, for example, in endurance sports, here you see one study in marathon runners that showed that simply the weekly running distance, 10 hours versus 2.5 hours, or 10 hours versus 7 hours and a half, so only minor differences, was a very good predictor of how fast you could run, in this case, the Boston Marathon. That's quite interesting, right? The more load or more training the athletes or the people here could do, the better, or there was a linear correlation to how well they performed in their marathon. So that is basically the same for every sport. If you are able to design a training program that allows you to do more training volume, right, overall duration slash training load, I would say, you are in general gonna be better at that sport. This again focuses on this specialization for hybrid sports. If you're doing a hyrox, for example, and your weakness is the burpee broad jumps, make sure that you add quite some volume that you can allow at high intensity, lower intensity of those burpee broad jumps into your training schedule. It seems logical, but many people forget that. And interestingly, the same goes for strength. This is a study where they looked at weekly training frequency effects on strength gain. And they found in this meta-analysis, so again, this overview study, that there is a beneficial effect of training more frequently your strength training. But when overall training load was equated, then these differences largely fell away. So this means that if you are able to add sufficient amount of load into your training program, that will be one of the major determinants of how well you perform in your training. Important consideration, and that's also how we think about all our training plans, to build up the load throughout the different time periods and different phases of the season. Cool. And then rule number 3 is a bit more specific, I would say, and also based on the studies that I have read quite in detail preparing for this video, is that HIIT or interval training pairs actually the best with strength training compared to medium intensity work. What do I mean with that? In this study, this biology of sport study that I showed in the beginning of the video, they show that if you look at the increase in peak VO2, the best results came from the group that combined HIIT training with strength training, better than, for example, medium intensity training, and certainly better in those barbell conditioning type of exercises. So that's something to take into consideration if you are watching this and you do a lot of CrossFit style workouts. If your goal is to improve your cardiovascular capacity, your overall capacity, maybe not always do those barbell cycling exercises right after strength. Maybe hop on a bike, do some bike intervals, and leave your mixed modality work for the next day or 2 days later if you want to, again, improve your cardiovascular capacity. If you want to build your strength, it probably doesn't really matter too much. So always think about, okay, what is the goal of my training and how should I approach this training to have the most bang for my buck in this session. So to summarize, let's look at those things from different perspectives. Let's say you are a pure hybrid athlete, right? Meaning that you want to improve your marathon, like your running, and your strength, whatever your powerlifting style. For sure, then I think it seems to be the best that you drop most of those CrossFit style workouts and train both modalities separately, endurance and strength. I think that's pretty straightforward. CrossFit, if you're a CrossFit athlete, it's always very tricky. It's not so easy to program for CrossFit, I always say, because there's way more interference. You don't only need pure endurance, you don't only need pure strength, you basically need power output. So there, mostly think about, okay, where is the training load? How can I progress in the different aspects of my training according to my schedule? If you have only 2 hours per day or whatever, 90 minutes per day, 5 times per week, and you have to add those sessions together, more the mixed modalities and the back squat work and the strength work, just do it, right? There might be some interference, but it's better than doing only 1 hour and try to separate those, but it's actually not really working in your schedule and so on. Just add them together. It's maybe better because you can just keep increasing your training load. Then if you are a hyrox athlete, I think you have to be a little bit more careful and try to separate your sessions, certainly in certain parts of the season, where you do the low intensity work quite far away from your strength work, because we have seen here that is medium intensity, lower intensity, there is actually some interference with strength. So there I would watch out and try to separate. But again, if you are an everyday athlete and you just want to get better along the way, and you have to kind of add the lunges and the sled pushes with your more endurance work in the same session, just do it. There will be a slight interference, but don't worry too much. It's only very important, I would say, very, very important for athletes who want to get into the Elite 15, want to go to the semifinals or CrossFit Games. There, I think you have to really take care, because also recovery is going to be affected by adding or cramping everything together. And maybe there it's better to separate. Good. To end, I want to talk about a very good comment that we had on our previous video. As I said, this is kind of a follow-up of my previous video on the constraint hypothesis, because make sure I read all the comments. So if you also have something to say about this video, or you're not agreeing with some of the things I said, please go ahead. I'm very happy and keen to learn. So the question was from Romb9901. So would a heavy muscular person that lost weight and muscle size be able to raise or change their biological ceiling that I talked about? I think it's a very good question. And I think actually the simple answer is yes. Although most of the data on this biological ceiling is observational, we just observe that bigger fibers can only get that many capillaries, right? There's no causal effect. It still seems to be logical to assume that when a fiber goes down in size and keeps the capillaries, for example, you keep doing endurance, that the diffusion of oxygen and also the waste products, the move of waste products in and out the muscle is going to be easier. And that's also why I said in my last video, and I still stand with that opinion, is that hyrox athletes, when the sport progresses over time, they only will get leaner, sufficiently strong, but leaner to improve that diffusion capacity and to actually make sure that the ceiling is as high as possible in terms of capillary to fiber ratio. So very good question, made me think, but I do think indeed that if you want to build endurance to a very high extent, you cannot have too big muscles and cannot be too bulky. All right, that was it from my part today. If you get some value out of this video, please take 5 seconds of your time and like and also subscribe to the channel. It really helps out me, the algorithm. The algorithm is my friend when people like the video. If you want to learn more on our hybrid studies that I talked about in this video, how we did the setup, the details of the different tests we did, and also the details of the different results we got out of our, I think, 140 participants, just click the video that is popping up right now. See you in the next one. Thanks for watching and ciao.